In the last video, we introduced the sum and difference identities in trigonometry, which let you determine the sine, cosine, and tangent of angles that you might not know off the top of your head. How you do that is you use the angles that you do know. So, for example, we know 30, 45, and 60, and by adding or subtracting these together, we can figure out these values for, say, 45 plus 30 equals 75, or 60 minus 45 equals 15. We can figure out these values. In this video, I want to go over a more involved problem where you're given some constraints up at the top here, and you're asked to find the sine, cosine, and tangent of a few different angle sums. To solve this, you're going to start off by drawing a plot, and then using the information that they give you to draw out a couple of triangles. So we're going to start by looking at the alpha angle, which we're told it's between 0 and pi over 2. We're also told that the sine of that value is 3 over 5. So we can draw it out. We know that the hypotenuse is 5, the opposite side is 3, and here's our alpha value. We're going to want to know this side, and we can use the Pythagorean theorem. We also know this is a Pythagorean triple, so we already know the values for, but we can quickly do this out. 3 squared plus b squared equals 5 squared. 9 plus b squared equals 25. B squared equals 16. Square root of that, b equals 4. Okay. So we have our first triangle. Now we can move on to beta, which we're told is between pi and 3 pi over 2. So we're in the third quadrant. The reason it's important to know the quadrant is that cosine is negative in quadrants 2 and 3, and it is positive in 1 and 4. So we want to keep that in mind when we're drawing our triangle, and then when we're using the calculated values in our formulas. So now let's draw out what this actually is. So, cosine of beta is negative 5 over 13. So this is going to be our 13 line. This is 5, which is in the negative direction. And then we want to figure out what this side is. Again, this is a Pythagorean triple, so this is going to be 12. And this is beta. The next step is to figure out what the sine and cosine values are of alpha and beta. So over on the left here, I'll write it out. Sine of alpha is going to be equal to 3 over 5. We were actually given this in the problem. Sine of beta is going to be 12 over 13. Then we have cosine of alpha, which is going to be 4 over 5. And then cosine of beta, which is going to be negative 5 over 13. Actually, I missed this one. Sine is also negative in quadrant 3, so we want this to be negative 12 for 13. Okay, now that we have all of those values, what we're going to do is I'm going to shrink this down so it's not taking up the entire screen. And then we're going to start looking at this. So we're going to have sine of alpha plus beta. We're going to write out our sum formula, which is sine of alpha cosine of beta plus cosine of alpha sine of beta. And then we're going to use the values that we just calculated and plug them in. So this is going to be 3 over 5 times negative 5 over 13 plus 4 over 5 times negative 12 over 13. So it looks like a little ugly math, but nothing we can't handle. Negative 48 over 65. So we're actually going to add these numerators together. So that's going to be negative 63 over 65. And that's going to be the answer to our first problem. So this is negative 63 over 65. Awesome. Now we're going to move on to the second question. What is the cosine of alpha plus beta? Again, we're going to start by writing out the formula. Cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Plug in our values. 4 over 5 times negative 5 over 13 minus 3 over 5 times negative 12 over 13. All right, so this is going to be negative 20 over 65 plus these two are going to become positive. That's going to be 36 over 65. And that's going to equal 16 over 65. So there's our second answer. Finally, we have tangent, which I'll write out the sum formula for tangent, which is tangent of alpha plus beta equals tangent of alpha plus tangent of beta all over 1 minus tangent of alpha tangent of beta. So we didn't actually figure out what tangent was, and we could do that, but the thing to point out here is that tangent is still tangent, so tangent of alpha plus beta is equal to sine of alpha plus beta over the cosine of alpha plus beta, both of which we figured out over here. So we can just plug those in. Negative 63 over 65 all over 16 over 65. We flip it. These two will actually cancel out. And then we're going to have negative 63 over 16. So that is a much faster way of figuring that out. If you already know sine and cosine, you don't need to go through all of the hassle of figuring out tangent of alpha and tangent of beta and then plugging them in and going through the formula. You can just use what you know.